Today we're going to talk about how to go from a word chemical equation into a formula chemical equation. So say you were given this paragraph. Nickel 2 chloride dissolved in water plus sodium hydroxide dissolved in water produces solid nickel 2 hydroxide plus sodium chloride dissolved in water. What our goal for today is to take that paragraph and to turn it into a balanced chemical equation with symbols and subscripts. Okay? In science, we use chemical equations to describe a chemical reaction using formulas and symbols. Very similar to math. We have 3 plus 7 equals 10. We have 15 plus 8 equals 20 plus 30. What we're doing is we're just replacing numbers in math with chemical formulas. A chemical equation is an equation that represents two things that are sort of equal. Na and Cl are not equal, but when they combine together, they create a new substance, NaCl, and those atoms have to be balanced, like we saw a couple days ago. 15 plus 8, CH3 plus O2 makes H2O plus CO2. So it works the same way as a math equation, where these reactants are going to rearrange themselves to create equal number of atoms on the other side. They're just in a different format. So chemical equation is used to describe a chemical reaction using chemical formulas and other symbols. So what we're going to do is we're going to break apart this paragraph and we're going to turn it into symbols. Okay, so you might want to have two lines, a line to show work and then a line for your final answer. So here we'll do this. The first thing we see is nickel 2 chloride. Now that you know how to write the formula for nickel 2 chloride, that's what we have to do. So nickel 2 chloride is Ni plus 2 Cl. So when you drop, and that oxidation number of chlorine is -1. If you don't know where that came from, go back and study the ionic chemical formula notes. Okay, we're going to drop and swap it, and it's going to become NiCl2. So nickel 2 chloride gets replaced with NiCl2. Dissolved in water. So dissolved in water comes next. Dissolved in water means that its state of matter is going to be AQ. Plus. So the word plus means that I'm going to have a plus sign there. Sodium hydroxide. So sodium is Na plus 1. Hydroxide, remember, is a polyatomic ion, OH minus 1. So when you drop and swap it, it becomes NaOH. It also says it's dissolved in water, so we're going to put an AQ here. Produces, which is our arrow, solid nickel 2 hydroxide. So nickel is Ni. Its oxidation number is +2 because it is a transition metal, and hydroxide is OH minus 1. So when you drop and swap this correctly, it is NiOH2. It does say it's a solid, so we're going to put a subscript with S. And it says plus sodium chloride. So sodium chloride is Na plus 1. Chlorine is Cl minus 1. It becomes NaCl, and it says dissolved in water, so it's AQ. So we have enough information now to write these equations, and then of course, since we learned how to balance, we are going to balance them next. Let's go ahead and balance it. We have 2 hydroxides here, we have 1 hydroxide here, so let's go ahead and put a 2 there. So now I have 2 sodiums, so now I need to put a 2 here, and that gives me 2 chlorines, everything else should be balanced. So your final answer, after all that work, is this guy right here. Okay. So one thing to be sort of careful is that there are certain gases that are called diatomic gases, and there are 7 of them, and you have to memorize these 7. And what a diatomic gas is that if that gas appears alone, not in combination with any other element, so it's not part of a compound, it is solo elemental, it is more stable when it is written or bonded with itself. So for example, if you have oxygen gas, you aren't going to write it as O. You're going to write it as O2 because it's one of the diatomic gases. Now, when oxygen is bonded with something, it drops and swaps its oxidation number like normal. This is only if it is elemental. It is all by itself. These 7 diatomic gases get written with a subscript of 2. Now, there are 7 of them, and it's easy to kind of remember where they are because of the following. Hydrogen is the first one. The other 6 start at element number 7, and then they form a physical 7 on the periodic table down to iodine. So the 7 you have to memorize are H, N, O, F, Cl, Br, and I. So whenever you have the word hydrogen gas, nitrogen gas, oxygen gas, fluorine, chlorine, bromine, or iodine, they get written with subscripts of 2. And again, this is only if they are alone. If they are combined with something else, like if you have dinitrogen monoxide, or if you have sodium chloride, or if you have magnesium bromide, they are dropped and swapped like normal. This is only if they are alone and by themselves. They get written as diatomic. Okay, so just be careful about that. The other thing to note is this. For the transition metals, if the oxidation number of the transition metal is not given to you, there is a red, white, and blue periodic table that was handed to you either at the beginning of the year or recently. There is a bold number that is written above the transition metal to tell you what the most common oxidation number is of that transition metal. So if you are not able to find it any other way, if it's not given in Roman numeral, it's not given as a dropped and swap number, if there's no other way, you are to look at the bold number on the back of that periodic table. If there is more than 2 bold numbers, you go with the higher bold number. And if that confuses you, come back to this part of the video and remind yourself. Okay, so let's take a look here. Okay, so for example, we have zinc plus gold 2 nitrate reacts to form zinc nitrate and gold. So zinc, because it's not with anything, it's elemental, so it's the N. Now, do not put a 2 there. I just told you about diatomic gases. That is only for those 7. If anything else is by itself, it just gets written as Zn. Okay, don't put Zn's oxidation number. Zn is not bonded with anything. An oxidation number tells you what the charge is. When zinc is by itself, it has no charge, so it's 0. Okay, so then N gold 2 nitrate. So that is going to be gold 2 nitrate is going to be Au plus 2. That plus 2 comes from the Roman numeral. Nitrate. Nitrate is not the same as N. Nitrate is a polyatomic from the polyatomic list. It is NO3 minus 1. So it becomes Au NO32. Okay, so now we've gotten rid of those 2 things. Reacts to form, that is where your arrow comes into play. Zinc nitrate. So here's where I was just talking about. You have zinc, which is a transition metal, but there's no Roman numeral to tell you what its oxidation number is. So what you need to do, you have to go back, erase this and come back to it. If you go to this periodic table that looks like this, it's red, white, and blue. It should be red, white, and blue for you. You're going to go to, there's 2 sides to it. You're going to go to the side that looks like this, that has there's one side that has like geometric pictures. You're going to go to the other side. You're going to find zinc. And zinc is right here. There is a bold number above the zinc, which is 2, which means that its most common oxidation number is 2. In fact, zinc only has 1 oxidation number. So when you go to write zinc nitrate, someone forgot to put the oxidation number there, it's going to be zinc 2 nitrate. Okay, let me quickly just go back through here. AuNO3 2. So zinc 2 nitrate is going to be Zn plus 2, nitrate is NO3 minus 1. So it will be Zn NO3 2, like that, plus gold plus Au. Okay, now another big mistake. People say, okay, gold has an oxidation number of 2 over here, so that means I have to put a 2 here. When the elements are by themselves, they don't have oxidation numbers. Oxidation numbers tell you how many electrons you have gained, lost, or shared when you are bonded with something. If you're not bonded with anything, your oxidation number is 0. Okay, so just because it has gold 2 over here and you used it to drop and swap over here, when it is elemental, it does not have anything next to it. Same thing for zinc. You don't write a 2 there because it doesn't make sense. It's not losing electrons to take on a charge when it's by itself. Okay, so that is the final answer. One thing you do have to do though, because we're in honors chemistry, is you have to balance it. So the zincs, they are balanced with 1, the golds are balanced with 1, the NO3s are balanced with 2, so here we are actually already balanced. If an equation does not give you the state of matter, you don't have to put the state of matter, it would have to tell it to you in the equation. So here we don't need to put solid, liquid, gas, or aqueous. All right, gallium bromide. So we have gallium, which is Za plus 3 Br minus 1. So you do have to go through and do all of these tedious steps that you guys don't like to do, but you have to get GaBr3. And hydrogen gas. So here we have hydrogen. It's not bonded with anything, but it is diatomic. It's one of those diatomic 7s. So you are going to put a 2 down there. It reacts to form gallium hydride. Gallium hydride is going to be Ga plus 3. Hydrogen is plus, or in this case, it'll be -1. So why does hydrogen have a -1 here, but it has a 2 here? Because when hydrogen is with gallium, it is bonded with it. So it is doing something entirely different than when it is by itself and diatomic. So these don't have to be the same when you have a diatomic, or when you have, not even if you have a diatomic, if you have an element that's non-bonded on one side and that element is bonded on the other side, they aren't going to match. Okay. The other thing people want to do is this. They see the 2 here and they say, well, it has to match, so I'm going to put a 2 here. No, that's not how chemistry and nature works. You can't just put 2s and match your subscripts up so that your life is easier. It has to follow the rules of dropping and swapping and valence electrons. So even though you don't want them to be different numbers, 2 and 3, they are different numbers. You match them up later by adding coefficients. Okay, and then bromine gas. So bromine gas is Br. It is diatomic though, so it is going to be written as Br2. So now we get the fun job of balancing. Let's start with the bromines. We have 3 bromines here, 2 here. So let's go ahead and put a 2 and a 3 here to balance the bromines. Then the galliums are messed up. There's 2 here, 1 here. So let's go ahead and put a 2 in front of that gallium hydride. That makes these hydrogen 6. So if I come back over here and put a 3 there, I am now done. All right, let's take a look at this one. Lithium phosphate. I have Li plus 1. Phosphate is a polyatomic. I know it's polyatomic because the suffix is not IDE. So lithium phosphate is Li3. Oops, I'm trying to erase that. Li3 PO4 plus calcium fluoride. Calcium is Ca plus 2, fluoride is F1 minus. If you are having a hard time following where I'm getting these formulas from, go back and study the ionic compounds notes. It says it reacts to form calcium phosphate. do it up here. Calcium is Ca plus 2. Phosphate is PO4 3 minus. So this becomes Ca3 parentheses PO4 2. It's a long formula. And then lithium fluoride. Lithium, fluorine. And again, if I'm going too fast, you are free to pause, go back, fast forward, rewind, whatever you need to do. All right, now that we got that done, we need to balance. So I have two PO4s. Let me go ahead and balance those first. I'm going to put 2 there. Then I'm going to put a 6 in front of the lithiums to balance the lithiums. And then I have 6 fluorines. Let me put a 3 in front of here to balance the calciums. And then that magically balances the calciums on the other side. And I am done with that. Let's go ahead and do this one. This one is pretty easy. All right, so we have potassium metal. Potassium metal is not bonded with anything, so it is just a K. It is not diatomic, so you're not going to put a 2 down there. It says, and chlorine gas. So we have chlorine. Chlorine is diatomic though, so you have to memorize what those diatomic gases are. It combines to form potassium chloride. So if you do a little side work, potassium chloride looks like this, KCl. One of the biggest mistakes people do also is they don't go through the time to drop and swap the formula for potassium chloride. What they'll do is they'll just like say, oh, I'm going to be lazy and not do chemistry and I'm just going to put the K and the Cl together. No, you can't do that. You've got to follow the rules of valence electrons and how the potassium chlorine bond together. Okay, then you got to balance it, put a 2 here, put a 2 there, and you are done. Take a look at this one. Aluminum plus hydrogen chloride. Hydrogen chloride is going to be H positive, Cl minus, so that will be HCl. Reacts to form aluminum chloride. Aluminum chloride looks like this, Al3Cl minus 1, so it becomes AlCl3. And hydrogen gas. Hydrogen is diatomic, so it is written as H2. Notice the subscripts don't have to match up. You put coefficients in later to do that. So we're going to put 3 here. Ooh, I can already tell that that's not going to work. Let's go ahead and balance the hydrogens. So if I put a 3 here, that makes 3 hydrogens here, 2 here. I can't do a 3 and a 2. I'm going to have to do 6. So I'm going to erase this guy, and I'm going to put a 6 here and a 3 here to balance the hydrogens. I'm going to put a 2 here to balance the chlorines, and I'm going to put a 2 here to balance the aluminums. All right, and we will get to these in class later.